Good evening, everyone. Let us now begin with our topic today. Today, we are learning about the basics of epidemiology and biostatistics. It's a bit of a content heavy, a little fast paced session, so I would suggest you all sit with like a pen or paper or something because we would be discussing some numericals and things like that. Right. So, what all we would be talking about today? We would be talking briefly about the types of study designs, about the phases of a randomized clinical trial, incidence and prevalence, quantifying risk data, and measures of central tendency. Right. So, let us begin. First, let us talk about the types of epidemiological studies. I know Zainab has already covered this topic before, so we will just go through this in a brief way. So there are a lot of different types of epidemiological studies, but they are broadly classified into observational or non-experimental and interventional or experimental studies based on if we do any kind of intervention or not in that study. In experimental or interventional studies, we mainly classify those studies on the basis of randomization. Randomization, like we talked in the last session as well, that is when we randomly select the subjects of a study to even out any unknown bias or any unknown co-founders. Right. So if we randomize it, then it is a randomized clinical trial. And in non-randomized trials, we usually have field trials and community trials. In a field trial, we do interventions in real world settings among healthy individuals. So we can see if we can prevent some type of disease or improve from the general baseline health. So that is a field trial. And in a community trial, we actually look at uh, any intervention and its effectiveness in a community compared to what happens when a community doesn't get an intervention as a whole instead of just giving it to individuals. And that is about interventional studies. In observational studies, we usually have population based studies and individual based studies. And population based studies, we have again descriptive studies and analytical studies. In descriptive studies, we have health surveys where we just take a survey or like uh, a survey of the general population. And in a ecological study, we actually analyze the data that we find in the survey. Right? In individual based studies, once again, we can divide them into descriptive and analytical studies. In descriptive studies, we have case reports and case series in which we talk about either one particular case or a series of cases regarding one disease or one particular outcome. In analytical studies, we have cross-sectional studies, case control studies, and cohort studies. Cross-sectional studies are also called prevalence studies, and in those we usually take a snapshot of the population. Case control studies uh, are also known as case reference studies, and follow-up studies are also known as cohort studies are also known as follow-up studies. Since case control studies and cohort studies have been explained in depth in the previous sessions, I want to ask you guys a few questions in the form of polls to see if you guys remember what was taught in the previous sessions or not, like a kind of a refresher. Right. So Zainab, if you could put out the polls, the first two polls right now. Everybody, if you could go to the bottom right corner in the activities section, you can see the polls, and please feel free to answer the two polls. Okay, I can see that we almost everybody has answered. the questions. So, in which type of study is recall bias more likely to occur? Right. So, one person has answered cohort study, and the rest have answered case control study. So, the correct answer here is a case control study, right? Because it is we usually go uh, retrospective, right? Which of the following is true about cohort studies? So, in this, once again, I can see that one person has answered that they are retrospective by design, and others have answered that they start by selecting participants based on exposure status. So once again, the second option is correct. The first answer isn't completely wrong, but the second answer is more correct because cohort studies can be prospective as well as retrospective, and we can have cohort studies that are a mix of both. So that is why the second option is more correct. Right? But now that we have had a brief refresher on the types of cohort studies, we can move on to the phases of randomized clinical trials. Right? From the beginning of the discovery of a medical compound to its widespread distribution, there are lots of phases that a drug takes. Right? There are a few clinical phases and a few preclinical phases. So we will look at them in a little bit of a detail. First, in the preclinical phases or in the discovery phase, there are two stages. First, there is studies in the lab where we actually look at the chemistry and the biochemical properties of that product, of that compound, and without testing it on any humans or any animals or anything like that. And in the second stage is actually the stage in which we do studies on the animal models like rats or guinea pigs and stuff like that. It's all of this happens before any sort of clinical trial. Once the drug passes the preclinical phases, then it enters the clinical phases. There are 5 phases in a clinical phase part of a clinical trial. So in the phase 0, it is the first study we do, and in that we take a very few number of volunteers that are healthy, that don't have any disease, and we see how the drug actually metabolizes in the body by giving a very small amount of drug. That is what happens in phase 0 trials. In phase 1 trials, we again once again take healthy human volunteers, right? And we try to find out that how much of the dose of the drug the body can take. So it is basically dose escalation studies, and we can also see what the side effects are and what generally happens to the drug in the body. And that is what happens in phase 1 trial. In phase 2 trial, from here we can take on patients who actually have the disease. But in phase 2 trials, we do not take patients with any sort of comorbidities. We only take patients with just that disease. And we again aim to find out how effective this particular treatment is. And since we are taken a larger sample of volunteers, we can find out more about the side effects of the drug and how to manage the side effects of that drug. In phase 3 trials, now we take patients and participants with that disease and other comorbidities to once again look at how that drug works with the disease. But more importantly, in phase 3 trials, we look at how that drug is effective for the treatment compared to other drugs that are already present in the market, right? If it is just as effective or more effective. And we can also learn how that drug affects people's quality of lives or their day-to-day lives in phase 3. Once the drug passes the phase 3 trials, then it is government approved to be distributed to patient population in general. So phase 4 of clinical trial is actually post-marketing surveillance or post-marketing study, in which we actually go to the doctors who distribute this drug months and years after like the drug is already approved, and then we look at how the drug actually affects the wider population or like a population that it wasn't initially tested on. And this also helps us to find out the more rarer side effects of that drug. So that is what happens in phase 4 trial. So this is all the things that happens in a randomized control trial. Right now, let us look at the next topic, that is incidence and prevalence. So what is incidence? Incidence is the number of the new cases that occur in a given population in a given period of time. Right. So in the given period, incidence is the number of new cases of a disease upon the total population at risk, usually multiplied by 1,000, but if required, you can multiply it by 100 or 100,000 as well. Right. So, very simple example we'll take to just quickly clarify the concept. So, if I have a group of 10 women and 4 of them develop uterine cancer in a year, so what is the incidence of uterine cancer per 1,000? Can anybody can unmute themselves, or they can write in the chat box? Okay, somebody has written 2,500. Somebody has written 4,000. Sorry, 400. So the answer is 400. Okay, no worries. Since the incidence is the number of people, new cases, that is 4 upon total population at risk, that is 10 into 1,000. So 4 upon 10 into 1,000 is 400. 400 per 1,000 population. Very good. Right? But it is important to remember that the denominator is the total population at risk. So, for example, if I modify this a little and I say that in this group of 10 women, 3 of them got a hysterectomy, and now we are again talking about this group, right? So now what would be the incidence per 1,000? If you cannot like you don't need to do the entire multiplication division. Yeah, that is also, yeah. So Ovia has written that it is 4 upon 7 into 1,000, right? So that is correct, since the population at risk changed from 10 to 7, right? So that is something important, that it's a very small thing, but you shouldn't miss it in like questions and stuff, right? So that is about incidence. Now, let us talk about prevalence. So, prevalence is the total number of cases in a population. So, that is old cases and the new cases in a given period of time. So, prevalence is the number of total cases of a disease upon the total population at risk into 1,000. Right? Prevalence can be of two types. Period prevalence and point prevalence. So before we get to that, let us just look at this example, a very like small example once again, that I have a group of 100 women and 5 of them had breast cancer, right? And this year, 6 of them got diagnosed with breast cancer other than these 5, right? So what would be the prevalence per 1,000? Okay, right. Very good. Both of your answers are correct. Yes, that it is 5 plus 6 upon 100 into 1,000. So that will be 110 per 1,000 population. Right. So, like I said, prevalence can be point prevalence and period prevalence. So, point prevalence is the prevalence of whatever disease we are looking for in a particular point in time. So, generally, if they don't specify, they're usually asking for the point prevalence. And period prevalence is the prevalence over like a few months or a few years or whatever time period they want. Right. So, all these few concepts that we learned, incidence, prevalence, and types of prevalence. So let us see them again with the help of a small example. So let's say I have a group of 10 women and 5 of them developed candidiasis in like the first 6 months of this year. Right. So you can see one of them got it in January, 2 in February, 1 in April, and 1 in May. So what would be the incidence in just don't need to write the entire like sum or anything. Just tell me the numerator. In this case, it's fine. So what would be the incidence in February? And okay, Dr. Deepika has said 3. So see, I am only asking of the new cases, right? The incidents. So in February, only 2 women got, like there are only 2 new cases. So the incidence in February would be 2, right? If I ask that what is the incidence in what would be the prevalence in February, right? So if the first case they still have candidiasis till February, so the prevalence in February would be 3. Right? I hope that difference is clear. Right? Similarly, what would be the incidence in May? Right? 1. Great. And what would be the incidence in March, let's say? 0. Okay, yes, you're all right. Right? So that is about incidence. Now let us look at prevalences. Right? So let's say that the first case that got, like, she had the disease till May. The second case had the disease till April, and the third case had the disease till March. The fourth case who got it in April, and fourth and fifth case, they still had the disease till June. Right? So what would be the point prevalence of, let's say, March? 3 in the numerator, yeah. Right? Great. What would be the point prevalence of, let's say, June? 2. Okay, yes, 2. Right. And what would be the period prevalence from January to June if I want to look at the period prevalence of candidiasis? So what would, again, the numerator be? Right? 5, because all of them had that disease at some point or the other. Right? So this is basically like very simple kind of questions you would get asked for incidence and prevalence. Right? It is very important to understand that incidence tells you about the risk of that disease in a population, the risk to an individual. Right? And prevalence will tell you the burden of that disease on the population. And incidence and prevalence are actually related to each other, and we can look at their relationship with the help of this equation. Right? So the prevalence is incidence times the mean duration of the disease. Right? And the mean duration of the disease is dependent on either deaths or cure. That makes sense, because if you get a disease, you either get cured of that disease or you die of that disease. Right? So the, like, incidence and prevalence are related to each other by this example. Right? So we can try to understand the relationship a little better with the help of this like metaphor. Right? So let's say that there is this vessel full of rocks. Right? The rocks that are being thrown in, that signifies the incidence. The number of rocks that are in this vessel, they signify the prevalence. And that the rocks that are falling out, right, they are either falling out because of death or because of cure. So in this, if the death will increase, right, so more people will be leaving the vessel, right, and so thus prevalence will be decreasing. And if death will decrease, then more people will be staying in the vessel, so prevalence will actually be increasing. Right? Similar with cure. If cure increases, then prevalence will decrease, and if cure will decrease, then prevalence will increase. Right? So can anybody tell me, if incidence of the disease will increase, uh, sorry, if the incidence of the disease will remain the same, and death, the cure rate also remains the same, but the death rate decreases. For example, if we get any treatment, right, that decreases the death rate of that disease. Right? So the incidence remains the same, the cure rate remains the same, but the death rate decreases. So what will happen to the prevalence? Prevalence will increase. Right? Yes. As like you guys are saying, you are right. So sometimes if you look at a treatment modality and you are seeing that, oh, the prevalence is increasing, so that doesn't automatically mean that the therapy isn't effective. Right? So that was it about incidence and prevalence. Now, let us talk about quantifying risk. Right? So first of all, what is risk? So risk is just the probability or likelihood of some specific outcome or some specific event that occurs in a population in a period of time. Right? So that helps us quantify that what is the likelihood of some injury or some disease happening in a population. Right? So we can quantify risk broadly by two methods, with the help of relative risk and with the help of odds ratio. Right? So usually we use relative risk in cohort studies, and usually we get odds ratio from case control studies. So let us look at how to calculate these two things. Right? So relative risk, we can calculate it by incidence among exposed divided by incidence among non-exposed, right? So you would get the interpretation like whatever relative risk is, for example, 2, right? So what is exactly the interpretation of that? So that means that, for example, exposure is smoking and the disease is lung cancer, right? So, and the relative risk is 2. So that means that the incidence of lung cancer in exposed is that many times higher. So that is 2 times higher as compared to those among non-exposed. So in case this is a bit confusing to understand, or the uh, equation for that is a bit confusing to understand, so let us try to understand this further with the help of this example. Right, so let's say that I have a group of 50 women, right, and out of the 50, 17 have an infection of HPV, right? So you can see that in this, the green are the women who don't have the HPV infection, and the red are those who have the HPV infection, right? So out of the entire population, the chances of getting an infection would be 17 upon 50, just the general chances. So there would be 0.34 chance of one individual getting the infection, right? But not all of this population is one and the same. So we can divide this population into those who have multiple sexual partners, that are represented by the circles, and those who don't have multiple sexual partners, that are represented by the squares, right? So you can see that 25 of them don't have multiple sexual partners and 25 of them do. So out of these 25 and 25, the risk of getting HPV is not 0.34 in both of these cases, right? So what is the difference in risk? That we will understand by relative risk. So let us say that in the group who have multiple sexual partners, 12 of them have HPV and 12 of them don't. And in the group who don't have multiple sexual partners, 5 of them have HPV and 20 of them don't. Right? So you can say, see that in this way we have created a 2 by 2 table that we usually see in these kind of problems, right? Of disease versus non-disease, and exposure versus no exposure, and the exposure here being having multiple sexual partners. So this is the type of table you'd get in a cohort study. Right? So now we can see that what is the incidence of HPV among the exposed. So the incidence is 12 upon 25. So that is 0.48. And what is the incidence of the disease of HPV among those who are not exposed, among those who don't have multiple sexual partners? So that is 5 upon 25. That is 0.2. Right. So that is the incidences of the individual groups. So what would be the increase in incidence if when the risk factor is involved? So to get that, to get the relative risk, we will simply do a ratio of the two incidences. So that is 0.48 upon 0.2. So that is 2.4. So that gives us the relative risk. So how do we interpret this relative risk? If the relative risk is 1, that means that the exposure factor doesn't have any bearing on the disease. It doesn't increase the risk of the disease and it doesn't decrease the risk of the disease. If the relative risk is more than 1, right, that means that the factor is a risk factor. It increases the risk of having the disease compared to if you don't have the exposure. If the relative risk is less than 1, that means that it is a protective factor, that if you get exposed to this disease, you are less likely, if you get exposed to this particular factor, you are less likely to have the disease. So that is about relative risk. So let us try to solve a question regarding this, right? So a study was conducted to investigate the association between hormonal contraceptive use and the risk of developing breast cancer. So you had out of 1,000 users, 100 developing breast cancer, and out of 2,000 users, 50 developing breast cancer, right? So what is the relative risk of breast cancer that is associated with hormonal contraceptive use? You can give the full answer of relative risk. You can just give a answer in like fractions. That is also fine. If anybody would like to unmute themselves and answer, that is also fine.
0.5 by 4.
Yes, okay. I see somebody has answered 4. And Dr. Deepika, what did you say?
0.5 by 4.
Okay. Uh, that would be 1 by 8. Okay, the correct answer is 4. Let us try to just go step by step of what we did, and maybe we can figure out where was the mistake, right? So uh, here we know that out of 1,000 users, 100 had breast cancer. Out of 2,000 users, 50 had breast cancer, right? So the formula for relative risk is incidence among exposed upon incidence among non-exposed. So incidence among the users, that would be 100 upon 1,000, right? So that will be 0.1. And incidence among the non-users will be 50 upon 2,000. So that will be 0.025. So our relative risk will be 0.1 upon 0.025. So that comes out to 4. So
It was just a
Ovia has,
mathematical error on my end.
okay, no worries. So Ovia has answered correct that the relative risk is 4. Right. Now let us talk about odds ratio. So odds ratio gives us the strength of association in a case control study, because the case control study doesn't give us an incidence of the disease, so we cannot exactly use relative risk. So odds ratio is an estimate of the relative risk, right? It's a cross product ratio. So in odds ratio as well, it is very important to have the proper 2 by 2 table construction, right? So as you can see on the slide, that a proper 2 by 2 table for a case control study to get the odds ratio would be like this: that in the uh, columns you would have the disease present and absent, and in the rows you would have the exposure present and absent, right? So the cross product ratio, that is A into D divided by B into C, will give us the odds ratio. So the interpretation of odds ratio is similar to the interpretation of relative risk, right? That is, if odds ratio is equal to 1. So there is no difference in the odds of a disease because of the exposure, right? If the odds ratio is less than 1, that means that the odds of disease will lower with exposure compared to non-exposure, right? And if the odds ratio is more than 1, then the odds of disease will increase with exposure as compared to those without the exposure. Right. So once again, let us try to solve a question regarding odds ratio. That we are doing a study investigating the relationship between physical inactivity and obesity. So out of the 150 people who are physically inactive, 60 are obese, and out of the 200 people who are physically active, 40 are obese. So what would be the odds ratio for the association between physical inactivity and obesity? So once again, feel free to unmute yourself or feel free to write in the chat box.
Doctor, is it 60 into 160 upon 40 into 90?
First, let us see if anybody else answers. Okay. But you are right though, Dr. Deepika. It is 60 into 160 divided by, okay, yes, somebody has answered 2.66. That is also very correct, right? Somebody has agreed with you as well. So the answer is that only, because in odds ratio, we would get A into D multiplied by B into C. It's a cross product ratio, right? So when we put the numbers accordingly, we would get 60 into 160 divided by 40 into 90. That would be 2.66 or 2.67, right? Does anybody have any doubts until now?
Hi, just one. Uh, like the relative risk, does the odds ratio being less than one also indicate a protective factor, or just that the odds are less?
No, that also can indicate a protective factor. Yes.
All right, thank you.
Now let us talk about data. right? So what is data? So it is just the observations or measurements or whatever information that you have collected to answer your research question, right? So data can be of many types. Basically, broadly it is divided into qualitative and quantitative data, depending on if it can be measured numerically or not, right? Quantitative data is further divided into continuous data and discrete data, and qualitative data is further divided into ordinal data and nominal data, right? So it is important that we understand that whatever set of data we get, what type of data it is, right? So first let us talk about quantitative data, and in that let us talk about continuous data. So continuous data is that data that in theory you can take any value of or any interval, right? For example, gestational age. So gestational age, first of all, it is numerical, right? It can be in numbers, and it isn't just 24 weeks or 25 weeks. It can be 24.3 weeks, 36.5 weeks, any value within the range, as much as range as we can take, uh, that we can take with gestational age. So it is a type of continuous data. Or we can look at serum progesterone levels. So that again can be in integers, or it can be in fractions, like 15.2 or 22.7. So these are all examples of continuous data, like the birth weight of a newborn. So we can take that in 3.216 gram or things like that, or maternal height, right? Then we have discrete data. So discrete data is once again numerical data, but that is one that we can only take at specific numerical values, and we cannot take the data between those numerical values, right? For example, a number of live births. So we cannot have 1.2 live births or 3.6 live births, right? So there would be no fractions or no integers here, or the number of antenatal visits, or the number of miscarriages, right, or the number of embryos implanted. So that will always be in whole numbers. That is discrete data. Then we have qualitative data. So in qualitative data, there is nominal and ordinal. So nominal data is a qualitative data with no ordered categories, right? So for example, blood group. So we have AB, and O blood group, but there is no specific order or hierarchy inherent in that group. So it is example of nominal data. Or if there is a presence of a disease like gestational diabetes, so yes or no. So you cannot have like specific order in that, right? Or the fetal sex or contraceptive method. So these are all examples of nominal data. On the other hand, ordinal data is qualitative data that has ordered categories. For example, the severity of anemia. So it goes mild, moderate, severe. It has a inherent order. It is not moderate, mild, severe. Or the stages of cervical cancer. It's not stage 3, stage 1, stage 4, stage 2. Right? It has a proper increasing, decreasing order. Or the grading of pelvic organ prolapse, or the pain intensity during labor. So it has a order in itself, right? So let us try to see a few examples, and then you can tell me what type of data it is. Zenap, if you could post the two polls, and if you guys can just answer those polls, or what type of data those are. In case somebody doesn't know, agar scoring is basically score you do like a scoring of the like health of the baby just after it is born. So like you look at a few parameters, and based on that you do like a 0 to 9, like a 0 to 10 scoring. And like if it's like less than 7, then it is normal. If it is more than that, sorry, if it is more than 7, it is normal. If it is less than 7, it is abnormal, like that. Okay. So I think everybody has answered. uh, Maybe just wait a few, one more minute. Okay. So first question was, what type of data is hemoglobin concentration? Right. So four people have answered continuous, and then one person has answered nominal and discrete. So the answer is continuous data, because hemoglobin concentration can be a numerical value within, like you can have numbers within integers, right? So it can be 10.2 or it can be 11.6. It doesn't need to be like either 10 or 11 or 12, right? So it is an example of continuous data. And what type of data is APGAR scoring? So APGAR scoring is two people have answered discrete and the rest have answered ordinal. So it is actually ordinal data, because it is a qualitative if you might not be familiar with APGAR scoring, so it might be a little confusing, but it is an example of qualitative data, and in that there is an inherent category. So it is an example of ordinal data. Okay. Now let us move on to measurement of central tendency. Okay, I see somebody has raised their hands. Yes, Dr. Deepika.
Yeah, I just wanted to confirm that though we are measuring various factors in APGAR scoring, but the end result is numerical in nature. So I was unable to distinguish between ordinal and discrete.
APGAR scoring, like you measure things like the rate heart rate of sorry, the heart rate of the baby and the respiratory rate. And if it falls, like if for example the respiratory rate is more than 50, so you give it like a score 1, or if it is less than 50, to give it a score 0, right? So like that you add up the numbers. It isn't like a you're measuring the height of somebody or the weight of somebody. So it is a numerical value, but it is the same type of categorization, like you categorize pain as mild, moderate, and severe. Does that
Okay,
make
thank you.
sense?
Yes, yes.
Okay.
Thank you.
Okay. Now let us look at measures of central tendency, right? So for before that, we have to look at what is normal distribution, right? So once we have collected however much data we want to collect, and if we plot it on a chart, so what type of distribution we would get, right? So normal distribution, also called Gaussian distribution or standard distribution, this is the distribution you get uh, of a quantitative variables in such a way that it is symmetrical, and you have a middle value with the same mean, same median, and same mode. So these all three these concepts are described later, right? And like you can see that you get a bell shaped curve with the frequencies tapering off. So basically I'm just describing this type of curve that you should get in a normal set of values. And for example, if I'm measuring the height of all of us, and if I plot that on a chart, so if there is no kind of outlying values, if one of us isn't too tall or too short, right? So we would get a normal type of distribution. So we would get this type of bell shaped distribution curve, right? So for every set of data we cannot do this type of distribution, but we can understand the data with the help of a few factors, like for example mean, and the like median and mode, right? So mean is simply the average, so it's just this sum of all the variables divided by the number of values, right? What is median? So median is the middlemost value. Once you take all of the numerical data and you arrange it in a ascending or a descending order, so the middlemost value would be the median, right? So for example, you have an odd number of values, so in that you can very easily find the median, because it's the middlemost value, right? In a when you arrange the data in a ascending or a descending order. But if you have an even number of total values, so you would have two middle values. So then what is the median? For such a distribution, you take the two middlemost values and you take out the average of that value. So that would be the median. Right? And the third measure is mode. So mode is just the most frequently occurring or most commonly occurring value in a distribution curve. So data, depending on the mode, data can be unimodal, like you can see in the figure, right? That unimodal data has a distribution with just one most frequent value. For example, gestational age at delivery. If I plot the gestational age at delivery of 50 women on a curve, I would get a unimodal type of distribution, because there would be one middlemost value, right, around 30 at 40 weeks. That would be the most common value. Then data could be bimodal. And that means that a distribution will have two most frequent values. For example, if I plot the age of diagnosis of PCOS of various patients, so I would get two peaks in this data. One peak I would get in the teenage years, because that is when girls who have PCOS, they get menstrual irregularities, and because of that they get diagnosed. And another peak I would get in the later 20s or early 30s, because that is when women with PCOS who suffer from infertility, they tend to get diagnosed. So that would be a bimodal distribution, right? And data could also have multimodal distribution. That means that you have frequent multiple values. For example, age at first pregnancy, so that could have a peak at early, or that could have a peak at late teens, that could have a peak at mid 20s, and that could have a peak at early 30s, right? So in this way we can study the data using mean, median, and mode. Right. So when I talked about normal distribution, I told you it has a symmetrical bell-shaped curve. But if a curve has any kind of asymmetry, right, because of uh, different variables, so that asymmetry is called skew, right? So as you can see in this figure, you could have positive skew or you could have negative skew. Right sided is the like positive skew is also called right skew, and negative skew is also called left skew. So again, as you can see in this figure, that in a symmetrical or Gaussian distribution, mean, median, and mode will coincide, but generally we don't get symmetrical distribution. There is some kind of skew. So in that, mean, median, and mode will all be different, right? So how does central tendency differ in different type of skews, that we will see. So in a normal distribution, mean, like I said, mean, median, and mode will all be equal to each other and they will coincide, right? But in a right or a positive skew distribution, mean will be greater than median and median will be greater than mode. So mean would be the largest value. And in a left or a negative skew distribution, mean would be smaller than median, would be smaller than mode. So mode will be the largest value in a negative skew distribution. This is about different types of skews. Now let us look at outliers. So outliers is that if I have uh, a distribution like all the different types of values. For example, I'm taking a group of women and I'm looking at the age of first pregnancy, right? So a lot of them in their 20s, or and one of them is like 37, right? So if in these people I try to find out the age, because of that one or two outliers, the few of these measures of central tendency will be affected a lot, and that can change our inferences that we are trying to make for the data. So what factor would be the most affected measure? So mean would be the most affected in case of an outlier. That's why we use mean in a data that is symmetric and that doesn't have any type of extreme values, right? On the other hand, what factor is the least affected? So mode is the least affected, right? And we use mode for categorical data, or when we want to identify just what is the most frequent occurrence, right? But what measure we use that is the most preferred in the case of outliers? So median, right? Median, it is easier to calculate than mode in most cases, and that doesn't get affected a lot by outliers. So that is very useful and much preferable in a data set with outliers or with skewed distribution, right? Uh, Now let us just look at a few more questions that are being posted on the chat box uh, to find out the relative risk and the odds ratio like we did before. If you could post a question, Zanab. I have posted the question in the chat box. A cohort study examines the relationship between gestational diabetes and preterm birth. So, among 1,500 people with gestational diabetes, 150 had a preterm birth, and among 3,500 people without gestational diabetes, 70 had a preterm birth. So what is the relative risk of preterm birth that is associated with gestational diabetes? Once again, you guys can answer in uh, fractions or by unmuting yourself or by answering the risk in the chat box. Also, if anybody has any doubts up until now, please feel free to unmute yourself or put in the chat box. Okay, Dr. Deepika has answered 5. See? Okay. I'm so sorry. I had some network issues, so I just lost my connection for a bit. I can see that a few more people have answered 5, and you guys are absolutely correct, right? Like I have posted a longer explanation for the others in the chat box, but you can see that the relative risk is 5. So that means that people with gestational diabetes are 5 times more likely to have a preterm birth, those compared to those who don't have gestational diabetes, right? Similarly, let us look at this question with where you have to calculate the odds ratio. A research study examines the association between use of a specific medication and the occurrence of severe menstruation cramps. So, in a sample of 500 people using this medication, 80 had severe menstrual cramps, and in a control group of 700 people not using the medication, 40 had severe menstrual cramps. So, what is the odds ratio of the association between medicine use and menstrual cramps? Okay, I see Dr. Deepika has answered 3. So 22 by 7. Okay. Okay. 3.14. Yes. Shashank has also answered 22 by 7. Okay, yes. You are both correct. Right. The answer is 22 by 7 or 3.14. Again, as you can see, in the odds ratio, we do cross product ratio, right? So it is A multiplied by D upon B multiplied by C by making a 2 by 2 table. And when we put in the values, you would get 22 upon 7 or 3.14. Right. Does anybody has any kind of doubts uh, during the whole session?
Hi. For the last slide that you showed with the outliers and who is most affected and least affected, could you possibly give examples?
Uh, what do you mean by example? Uh,
In the sense that um, how are we so sure like the
okay,
least affected is the
okay.
mode?
How does it affect? Okay,
Yeah, yeah,
okay.
yeah.
Uh, I get your point. Um, okay. So you are. Um, so for example, once again, let us take the height of everybody here, right? So, like 120, 120, 125, 130, and somebody who is like very tall and like 170, right? So if we don't have that 170, then we would get a normal mean median mode. But if it is 170, then like I said, mean is the addition of all the values upon the number of values. So mean would be very much affected, right? uh,
Oh, so
if
which
I
value is affected most by an extreme value coming in? Okay, okay, got it, got it. Thank you.
That is mean, yeah,
Yeah,
and least affected is mode.
yeah.
Okay. Does anybody else have any other questions? Yeah. Okay, then we are at the end of our session today. If you guys even have any further questions, feel free to put it in the WhatsApp group. And also, I am sharing the post event form. So please remember to fill the post event form within the next 2 hours so that you can get the certificate. Just a second. And by that, till then, can everybody just turn on their cameras for a minute so I can take a quick photograph?
Rajvi, don't worry. I'll just put the post-event questionnaire on the chat box.
Not an issue. I've put the post event question.
Thank you so much, Uvia and Dr. Deepika, for switching on your cameras. We would like to see others as well so that we have like a nice photograph.
Thank you all for attending, and yeah, have a good evening.
It was wonderful having you all. I hope you all were able to learn something. Have a good night and a good weekend. Bye, everyone.